All right, more examples related to law of sine. This is a landscaping. Thomas needs to determine the height of a tree before cutting it down to be sure it will not fall on a nearby fence. The angle of elevation of a tree from one position on the flat path from the tree is 30 degrees. So there is an elevation 30 degrees. And from a second position 40 feet farther along, this path is 20 degrees. What is the height of the tree? So let's take care of the 30 degrees. So we have elevation. This is the ground, horizontal, and then elevation 30 degrees. So let me draw a line like this. So this is another straight line. Starting at right here, at 0 degree, you have to lift this up 30 degree. So let's say this is 30 degree. Then this is my 30 degree elevation. And then this is the height of the tree. Right here is the height of the tree. So this one I call that a tree. And then I call that a height. I'm going to use h. And then this is a 90 degree. So that is the elevation 30 degree. So what is the other angle? So 30, 90 degree. So we have 90 minus 30. Oh, actually 180. Let's don't just cross this out. So we have 180. 180 minus 90, the right angle, and then minus 30 equals to 60. So this is a 60 degree, easy to find. And then what else do we have? There is a second position, right? So second position, let's switch color. So second position is 40 feet away. So this is my first. And then second position is 40 feet away. So I'm going to draw another line. And then this is my second position. That is 40 feet away. And 20 degree. Along this path, it is 20 degree. I think they meant the 20 degrees elevation. So we have to connect this point to the top of the tree. So 20 degree. This is 20 degree. All right. Okay. What are we looking for? How high is the tree, right? Okay, that would be h. Okay, let's start the work. So first, let's look at the orange triangle. We have 40, okay, but from the first point to the bottom of the tree, we don't know. Let's call this x. So that means we have sine of 30 degree. So that is facing h equals to sine of 60 degree. That is facing x. I know there are two unknowns. This one is not solvable yet. But let's put x on one side because we are going to perform a substitution. So cross multiply. X times sine of 30 degree equals to h times sine of 60 degree. And then we have x equals to sine of 30 degree. Oh, actually, we have to write the h first. So we have h times sine of 60 degree divided by sine of 30 degree. Okay, this is not solvable yet. Let's set up another law of sine. So another law of sine, I will be using the bigger triangle. So the orange plus the pink. Okay, so the other one, let's follow the color code. So I'm going to use the pink. So that will be sine of 20 degree. That is facing the height of the tree h equals to, and then the angle, the 60 degree, I need to find the other angle. So for the big triangle, I'm going to do a math right here. So the big triangle, so this is my big triangle. Let's draw that first. Okay, so this is a 20 degree. This is a 90 degree. I am looking for these degrees right here. How do I find that degree? So this one I can do 180 minus the right angle minus 20 equals to 70, right? So that means the angle right here, is 70 degree. But we have a cut, so let's erase this for now. We have a cut, so the cut is right here. So that is a 60 degree. what about this piece? So to find that piece, we take 70 minus 60 equals to 10. So this is a 10 degree, not 18. This is a 10 degree. Okay, so sine 20, so using the bigger triangle, I can do a sine of 70 degrees. So this, the sum, is equals to 70 degrees, and that is facing the ground, right? So the ground is x plus 40. And then we are trying to isolate x on one side. And what do we have? This one we have x plus 40 times sine of 20 degree equals to h times sine of 70 degree. And then we have to distribute the sine 20. So x times sine of 20 degree plus 40 times sine of 20 degree equals to h times sine of 70 degree. And then we subtract 40 times sine and then divided by sine, right? So x is equals to h times sine of 70 degree, subtract 40 times sine 20, and then divided by sine of 20 degree. Okay, what do we have right here? So let's use the highlighter. So we have x equals to this, and then we have x equals to this, right? So basically we have two equations. They are x equals to something. So that means I can set the right hand side equals to each other. So set them equal. And then we solve for h. All right, so let's set them equal. So we have h times sine of 60 divided by sine of 30 equals to, this one we can cut this into two pieces, right? Remember that. So let's say we have a minus b divided by c. That is the same as a divided by c minus b divided by c. So we can do h times sine of 70 divided by sine of 20 minus 40 times sine 20 divided by sine of 20. So this sine 20 and the sine 20 can be cancelled. So we only have a minus 40 left. And then the one with an h, let's toss that to the left. So we have h times sine of 60 divided by sine of 30 minus h sine 70 divided by sine of 20. And then we factor out the h. So we factor out the h. We have sine 60 divided by sine 30 minus sine 70 divided by sine 20. And then we have everything. Oh, actually this will be an equal because we put this term to the other side, right? So we have everything equals to is a minus 40. Minus 40. So this will be a minus 40. So this will be a minus 40. Okay, don't be too creative. You cannot get rid of the sign, all right? So we have h equals to negative 40 divided by sine 60 divided by sine 30 minus sine 70 divided by sine of 20. So this we have to calculate what that equals to. So I am going to try my best to avoid round off error. First, we approximate the denominator. Okay, use parenthesis. Sine of 60. I already started with the parenthesis. Close parenthesis for the sine, divided by sine 30, close parenthesis for the sine, and then close parenthesis for the whole fraction. And then you subtract, open parenthesis first, sine of 70, close parenthesis for the sine, divided by sine of 20, close parenthesis for the sine, close parenthesis for the whole fraction. So we have one fraction minus another fraction. And that gives me an approximation, right? So we are not going to round these things. I am going to take negative 40 divided by this answer. But how do you divide it by this answer? To do so, do you see that there is a word ANS right above the negative sign? The negative sign is between the decimal key and the enter key. So we are going to type divide that answers. So we will type second. And then you type the negative key. So you see ANS, the answer of the previous computation. And then you type tab equal. So now you have the height is around 39.39 feet. And that is the answer of this question. All right, let's do the last one. So the last one is a Leaning Tower of Pisa. The famous Leaning Tower of Pisa was originally 184.5 feet high at a distance of 123 feet. So they got everything in the picture from the base of the tower. The angle of elevation is 60 degrees. They got that in the picture as well. Find the angle RPQ indicated in the figure. Also find the perpendicular distance from R to PQ. Okay, let's draw a triangle. So we have this, and then this, and then this one. Keep the line straight. So this is my P, this is my Q, this is my 60 degree, and then this is my point R, and then we have a height, right? So this is the height. The perpendicular distance from R to line PQ. What are they looking for? Oh, they also have a 184.5 feet. And then they are looking for RPQ, so they don't know this, and they don't know this either. All right, so let's find I need an one more thing. This is a 120 feet. One thing that I need to find is I want to find the angle R. Right? So let's find angle R first. So angle R, because after I found angle R, I take 180, subtract angle R, subtract angle Q, then I will get angle P. So let's do the work. We have sine of 60 degree divided by 184.5. So they are facing each other, right? 60 and 184.5. That is equals to sine, let's call it, just call it R, divided by 123 feet. That is the base. You cross multiply. Times sine of R. And then divide both sides by 184. That is equal to sine of R, and then R is equal to inverse sine 123 times sine of 60 divided by 184.5. All right, let's see what that equals to. So degree mode, we have inverse sine, and then we have 123 times sine 60 degree, close parenthesis for the 60, divided by 184.5, close parenthesis for the inverse sine. So we have around 35.3 degree. So that is my angle R. And then you want to find angle P, right? So technically they call that angle RPQ. So that is the sum of three interior angles, subtract the given 60 degree, subtract angle R. So that is equals to around 84.7 degrees. So that is your angle P. All right. And then the one last thing is they want to find the height. So in order to find the height, I will be using a right triangle. So let's cut a piece of the triangle. Let's cut this piece. Let's cut this piece. So I am going to draw a triangle right here. Oh, I use my highlighter. So we have this, and then we have the perpendicular line, and then this is the length of the tower, 184.5, right angle, and then 84.7. So this one I am looking for height. I will be using sine, SOX, so sine of 84.7 right triangle trigonometry, SOH, that is equals to opposite divided by hypotenuse. And then you solve for x, so h is equals to 184.5 times sine of 84.7 degree. So h is approximately equal to 184.5 times sine of 84.7 degree. So that is around 183.72 feet. So that is the vertical distance. All right, so that will be all in this part. I will see you all in the next lesson.